When upgrading from a 60 amp service to a 200 amp service, the existing wiring is generally insufficient to handle the increased amperage. The National Electrical Code, or NEC, requires a 4-wire system for a 200 amp service. The 4-wire system consists of 2 hot wires, which can be black or red, 1 neutral wire, which is white, and 1 ground wire, which is bare copper or green insulated. There are several benefits to using a 4-wire system. Firstly, it provides a dedicated neutral path for current return. Secondly, it reduces voltage drop and improves power quality. Thirdly, it ensures proper grounding and safety. The procedure for upgrading to a 4-wire system involves several steps. 1. Call your local utility company to disconnect the existing service. 2. Install a new meter base that is rated for 200 amps. 3. Run new 4-wire feeder cables from the meter base to the breaker box. 4. Install transfer switch at the meter base to act as the main disconnect. 5. Connect the new feed cables to the breaker box and transfer switch. 6. Call your local utility company to reconnect the service. 7. Get a permit from the local building department and have the work inspected. It is recommended to hire a licensed electrician for this project to ensure safety and compliance with electrical codes. The size of the feeder cables will depend on the distance to the breaker box and the amperage of the service. The transfer switch must be rated for the same amperage as the service. A ground rod should be installed near the meter base to provide a proper grounding system. When upgrading electrical service, safety is paramount. Ensure all work is performed according to the National Electrical Code and local regulations. The 4-wire system is crucial for modern electrical services because it provides a safe and efficient way to distribute power. Each wire in the system serves a specific purpose and contributes to the overall functionality and safety of the electrical system. The 2 hot wires, typically color black and red, carry the alternating current from the utility transformer to the electrical panel. These wires provide the voltage necessary to power appliances and devices in the building. In a 200 amp service, these wires must be sized appropriately to handle the increased current load. The neutral wire, which is white, provides a return path for the current back to the source. This wire is connected to ground at the service entrance, ensuring that the voltage between the neutral and ground is close to 0 volts. The neutral wire is essential for maintaining a balanced electrical system. The ground wire, which is either bare copper or green insulated, provides a path for fault current to flow back to the source in the event of a short circuit or ground fault. This wire is connected to ground rods or a grounding electrode system, which helps to protect people from electric shock. The ground wire is a critical safety component of the electrical system. When upgrading to a 200 amp service, it's important to select the correct size and type of feeder cables. The size of the cables will depend on the distance from the meter base to the breaker box, as well as the ampacity required for the service. The National Electrical Code provides tables and guidelines for determining the appropriate wire size based on these factors. It's also important to consider the insulation type and temperature rating of the cables. Common types of feeder cables include copper and aluminum conductors. Copper conductors have a higher conductivity than aluminum conductors, but they are also more expensive. Aluminum conductors are lighter and more cost-effective, but they require larger sizes to carry the same amount of current as copper conductors. When selecting feeder cables, it's important to consult with a licensed electrician and follow the recommendations of the National Electrical Code. The transfer switch acts as a main disconnect for the electrical service. It allows you to safely disconnect power to the breaker box in the event of an emergency or when performing maintenance on the electrical system. The transfer switch must be rated for the same amperage as the service and should be installed in a readily accessible location. When installing a transfer switch, it's important to follow the manufacturer's instructions and ensure that all connections are made properly. The transfer switch should be clearly labeled to indicate its purpose and how to operate it. Grounding is a critical aspect of electrical safety. A proper grounding system helps to protect people from electric shock and prevents damage to electrical equipment. The grounding system should consist of ground rods or a grounding electrode system that is connected to the ground wire in the electrical panel. The ground rod should be driven into the earth to a depth that ensures good contact with the soil. The grounding electrode system should be installed according to the requirements of the National Electrical Code. It's important to inspect the grounding system periodically to ensure that it is in good condition and functioning properly. Permits and inspections are required for most electrical work. Before starting any electrical project, it's important to obtain the necessary permits from the local building department. The permit process ensures that the work is performed according to code and that it is safe for the occupants of the building. After the work is completed, the building department will send an inspector to verify that the work has been done properly. The inspection process helps to identify any potential problems and ensures that the electrical system is safe and compliant with code. Hiring a licensed electrician is recommended for any electrical work. A licensed electrician has the knowledge, skills, and experience to perform electrical work safely and according to code. An electrician can help you to plan your project, select the right materials, and ensure that the work is done properly. Hiring a licensed electrician can also help to protect you from liability in the event of an accident or injury. When hiring an electrician, it's important to check their credentials and make sure that they are licensed and insured. You should also ask for references and check their online reviews. Upgrading to a 200 amp service is a significant electrical project that requires careful planning and execution. By following the steps outlined above and consulting with a licensed electrician, you can ensure that your electrical system is safe, reliable, and compliant with code. Remember to prioritize safety and always disconnect power before working on any electrical circuits. The 4-wire system is the standard for modern electrical services and provides numerous benefits, including improved safety, reduced voltage drop, and better power quality. By understanding the components and function of a 4-wire system, you can make informed decisions about your electrical needs and ensure that your home is powered safely and efficiently. Before starting any electrical work, it is important to understand the local electrical codes and regulations. These codes are designed to protect people and property from electrical hazards. The National Electrical Code, or NEC, is a widely adopted set of standards for electrical installations. However, local jurisdictions may have their own amendments or additions to the NEC. It is important to consult with the local building department or a licensed electrician to determine the specific requirements for your area. Failure to comply with local electrical codes can result in fines, penalties, and even the rejection of your electrical installation. Therefore, it is essential to familiarize yourself with the local codes and regulations before starting any electrical work. The selection of appropriate electrical components is crucial for the safety and reliability of your electrical system. Electrical components, such as circuit breakers, switches, and receptacles, must be rated for the voltage and current that they will be carrying. It is important to choose components that are listed by a recognized testing laboratory, such as Underwriters Laboratories or UL. UL-listed components have been tested and certified to meet safety standards. Using non-listed components can increase the risk of electrical shock, fire, and equipment damage. When selecting electrical components, it is also important to consider the environment in which they will be used. For example, components used in wet or damp locations must be rated for those conditions. Proper installation techniques are essential for the safe and reliable operation of your electrical system. Electrical connections must be made properly to ensure good contact and prevent overheating. Wire terminations must be tightened to the correct torque specifications. Wires must be protected from physical damage. Electrical boxes must be properly grounded. Following proper installation techniques can help to prevent electrical problems and ensure the safety of your electrical system. Regular maintenance is important for keeping your electrical system in good working order. Electrical panels should be inspected regularly for signs of damage or corrosion. Circuit breakers should be tested periodically to ensure that they are functioning properly. Electrical outlets and switches should be checked for loose connections. Ground fault circuit interrupters, or GFCIs, should be tested monthly to ensure that they are providing protection from electrical shock. Performing regular maintenance can help to identify and correct potential problems before they become serious. Electrical safety is everyone's responsibility. Always disconnect power before working on any electrical circuits. Use insulated tools and equipment. Wear appropriate personal protective equipment, such as gloves and safety glasses. Never work on electrical circuits when you're wet or standing in water. If you are not comfortable working on electrical circuits, hire a licensed electrician. By following these safety precautions, you can help to prevent electrical accidents and injuries. Upgrading to a 200 amp service can provide numerous benefits, including increased capacity, improved reliability, and enhanced safety. However, it is important to plan the project carefully and follow all applicable codes and regulations. Hiring a licensed electrician is recommended to ensure that the work is done safely and properly. With proper planning and execution, upgrading to a 200 amp service can be a worthwhile investment that will provide years of trouble-free service. Consider the long-term electrical needs of your home when planning your electrical upgrade. Do you anticipate adding any new appliances or equipment in the future? Will you be installing an electric vehicle charger? Planning for future electrical needs can help you to avoid having to upgrade your electrical service again in the near future. When upgrading your electrical service, it is also a good time to consider upgrading other electrical components in your home, such as your electrical panel, wiring, and lighting fixtures. Upgrading these components can improve the overall efficiency and safety of your electrical system. Consider energy-efficient lighting options, such as LED bulbs, to reduce your energy consumption and save money on your electricity bill. Be aware of the potential hazards associated with working around electricity. Electricity can be dangerous and can cause serious injury or death. Always take precautions to protect yourself from electrical shock. Disconnect power before working on any electrical circuits. Use insulated tools and equipment. Wear appropriate personal protective equipment. If you are not comfortable working around electricity, hire a licensed electrician. Educate yourself about electrical safety. Learn about the potential hazards of electricity and how to protect yourself from electrical shock. Take a first aid course that includes training in how to respond to electrical shock victims. Be prepared to help others in the event of an electrical accident. Remember that electrical safety is everyone's responsibility. By taking precautions and following safety guidelines, you can help to prevent electrical accidents and injuries. The information provided in this discussion is for general informational purposes only and should not be considered as professional advice. Always consult with a qualified electrician or other professional for any specific electrical needs or concerns.